Hello class, this video is on angles, specifically angles within triangles. So we'll be focusing on two things, the triangle angle sum theorem and the exterior angle theorem. Before we get to it, there's some basic things that we need to get to. So first of all is, what is an angle? It is the space, specifically in degrees, of two intersecting lines. We're going to talk about the types of angles, things that you've seen before in the past. So we have acute angle, obtuse, and right. We're going to use inequalities and an equation, an equal symbol to describe this. So an acute angle, this is an angle that is, we're going to use this as less than 90 degrees. So just to draw like an angle here, 2 rays like this, that would be right less than 90 degrees. Obtuse, this would be something that is greater than 90 degrees. So an angle, if I draw a ray that goes here, right, this would be 90. That would be right an obtuse angle. And right from Pythagorean theorem, we should know that this is exactly equal to 90 degrees. So something that we've seen in the past before, right? 2 rays that are perpendicular to each other. A lot of this is filled out for you. So something that we should also know, triangle, the interior angle sums to 180 degrees. Now, along with this paper, you also have a triangle. I'd like for you to do two things with this triangle. Off to the left here, so why is this 180 degrees? We're gonna prove that. On this, maybe centered along this dot, I'd like for you to trace the outline of this triangle. So I'm just gonna draw something like this. Right, that's on top of this ray. So we'll say that this was the triangle at the beginning. Now this triangle, we're gonna look at the description here. Angles when cut form a straight line. We're gonna see that. Where I drew these two perforations, I like for you to cut or tear your triangle in those two areas. So right here, I'm gonna rip that and off to the left like this. So we have 3 pieces where each angle, these black darkened angles are formed. So why is this 180 degrees? So if we take all of these angles, I'm gonna put them on the line where their point, their vertex is on this center dot. If I take that, kind of form this right next to it, also pointed at it. Let's see if I can get it. And this last one, right, hopefully you see that when all angles form together, right, it actually makes a straight line. So this right here is 180 degrees. Right, when we took all of these 3 angles here, right, that made a straight line. At that point, I'd like for you to glue this in. I don't have glue, so I'm gonna actually tape it. Something like that. Yeah, perfect. So that's proving why it is 180 degrees. Okay. Now we're gonna get to the two main parts of these notes here. First is the triangle angle sum theorem, and this is something that we just described above. The sum of the measure of the interior angles of a triangle is 180 degrees. So if I take all angles in this triangle, right, x plus y plus z, it'll equal 180. So we're gonna use this idea and also our understanding of writing equations and solving equations to figure out angle measures. So the example underneath it, create and solve an equation to find the measure of each angle. So we should know that these 3 angles added together equals 180 degrees. I'm gonna highlight certain things here. I'm gonna highlight, if you have a highlighter, you're welcome to also do this. We're gonna highlight this angle A being 5x plus 5 and angle C being 3x plus 5. And we know that B right here, that right angle, this is 90 degrees. So we already know that one, but we need to figure out the other two. So We can write an equation. I'm going to take this first angle, angle A. We're going to put 5x plus 5. Angle C, 3x plus 5. And add it together with this 90 degrees. This should all equal 180. I know this is a lot of information, so I'm gonna highlight again, just like what I highlighted in the figure. We'll leave that 90. I don't have another color, so I'm gonna leave it. So we can combine in this. There's a lot of terms. Let's simplify. So we're gonna combine like terms. This 5x and this 3x make, well, if you add it together, equals 8x. We do have some other like terms, that being the 5 here, and this 90. 5 plus 5 plus 90. Well, 5 plus 5 is 10. 10 plus 90 is 100. And this all equals the same thing, same constant of 180. Now this becomes a two-step equation. So this, hopefully it now becomes something a little bit more familiar. We're gonna subtract 100 to both sides. This will be 8x equal to, that'll be 80. And I think you can see it after we divide by 8 to both sides, we're gonna get x equal to, looks like that's 10. Good. So we found the unknown here. Great. But the thing is, right, we have to think about the problem that we're trying to answer. So thinking back to that is we have to find the angle of A and C. So we use this. This isn't our final answer, but it helps us give us what is angle A and C. So angle A, I'll put A equal to, this is 5x plus 5. Now we already found x, which is 10. So we're going to put 5 times 10 plus 5. So I'm just plugging a 10 in for x. Now this, we can simplify. 5 times 10 is 50. Plus 5 is, A is going to be 55. Let's put our degree symbol. I guess going in alphabetical order, right, we can find measure of angle B. Well, B, we already found, no work really involved. It's 90 degrees. And measure of angle C, right, this is 3x plus 5. So let's plug in 10 in for x. So 3 times 10 is 30, plus 5 is our final angle of 35. So try to squeeze that in there. There's not too much room here. But if you take these three angles, you are surely going to find that this is going to be 180 degrees. I know there's a lot of work to set up, but after combining like terms and solving, this became quite pretty simple in the end. Going on to the last part, a part that you might not be familiar with is this, which is the exterior angle theorem, or you might also hear it as the exterior angle sum theorem. The exterior angle equals the non-adjacent angles of a triangle. So that's a lot of words there. So I think to simplify this, let's highlight certain things. What this is saying is the exterior angle. So in a triangle, right, these are all interior angles. The exterior angle is formed by the edge of a triangle, and it has a line segment that continues from one of the side lengths. Now, that is measure of angle D. We say that this is equal to, right, you can already see it here, this is equal to the other angles that are not next to it. That's why it says non-adjacent angles. So that's a relationship that, or you could try to discover. A plus B is going to be equal to this other angle. We're just calling it D for now. Okay. So to use this for the problem that we have, we don't have, right, A, B, and D. We do have 115 degrees. That's our exterior angle. It's on the outside. We're going to set this equal to the other two angles that are not adjacent to it. And with this information, we can figure out what this angle is right here. So setting this up, ooh, I didn't highlight this. Measure of angle A and B, that corresponds to 54 and x. So we're gonna put 54 plus x, or you could put x plus 54, it doesn't matter. This is gonna be equal to measure of angle D, in this case, is 115 degrees. Now this is a lot simpler than this right here, but we can subtract 54 to both sides. And here, this will become 1. This will become 6. So x is 61 degrees. So this value is 61 degrees. Okay. So we had this angle. We had this exterior angle. We found that one. We could actually find this one by maybe using 115 and 180, or adding these two and subtracting from 180. But in the end, we can find all angles from this, either using the triangle angle sum theorem or the exterior angle sum theorem. All right, that's been these notes. Let me know if you have any questions. Bye.